Hello Bobcats. Today we're going to talk about measurements during this video. Now, first, before we start measurements, I'd like to clarify types of observations. We have qualitative observations and quantitative observations. Now, qualitative observations are observations which we are using our senses like taste, touch, sight. We're using the senses to make an observation of properties and characteristics. Observations of properties and characteristics. Okay, so that would be, some examples would be odor, taste, color, texture, etc. These are considered subjective, which means that it depends on our perception. So if something's subjective, it depends on our perception, and not everybody perceives something the same way. So qualitative is very important in that let's say we need to know, make an observation. A lot of our chemical reactions, we know that a chemical reaction occurs when there's a change in color. And so we need to make an observation of color changes. Sometimes odor is a good observation, not always. Texture and so forth. The problem is that because it's subjective, what color you see may not be the same color that I see. You may see green, I may see blue, especially if somebody is colorblind. So it's very subjective, but it doesn't mean they're not important. The next one is quantitative observations. And quantitative observations depend on quantity, and we call those measurements. So quantitative observations are through measurements. Now, a measurement requires a number and a unit. And units are extremely important because if I just give you a number like 12, you don't know what I mean by 12. But if I say 12 centimeters, then you understand what that unit is. So units are critical. I meant to draw a exclamation mark, sorry. So they're very, very critical. So anytime you have to turn something in to me, if you do not include a unit with a number, you will not get credit for that work. Now, the other thing is that they're objective, and that means that measurements use standards agreed upon by the scientific or international community. So when you make one measurement somewhere in one country and you report it, another person in a different country can make the exact same type of measurement because we have a standard that we have for that measurement. A lot of times we call them standard international units. Okay, so measurements have standards, and therefore it'll be the same throughout the world, and we don't have to worry about the ambiguity that occurs with qualitative observations. Now, so since we talked about measurements, let's discuss the basic international measurements that occur. Okay, so we have basic SI measurements and units. SI stands for Standard International. So let's talk about those basic ones. And what I mean by basics are the ones that you do not have to do any calculations for. You can do direct measurement of. So let's make a table here because we're going to discuss quantity, what the quantity measured is. We're going to look at if we have a quantity, what variable do we use, or the symbol, the variable symbol in an equation. So there's the variable symbol. Quantity, variable symbol. What are the units of that quantity? And what are the symbols for those units? For the units. Okay, so first we will look at time. Time is a basic quantity that we measure. The symbol, if you were putting it into an equation, would be a small t for the variable. The unit, the base unit that we measure is a second. And then the second is representative with a small s. So we can actually measure that without doing any kind of calculations. The next one would be mass. So that's a base quantity, or quantity that we can measure directly. The unit that, or the symbol for the variable in an equation is an m. The international unit is kilograms, but a base unit that we're going to talk about is grams. So you can measure grams, and then we can say that there are kilograms, which are 1,000 grams. Now grams are represented with a small g. The next unit that can be directly measured, or quantity that can be directly measured, is distance. And distance is represented in an equation with a d. And the base unit of distance is a meter. And we use the small m for the meter. The next would be temperature. And the base unit for temperature, or the scientific unit that we're going to talk about, well, I'm sorry, the variable would be a capital T. You can't use a small t because small t is already used for time. We're going to use a capital T. And Kelvin is the unit that the scientific community uses. So I'm going to write the capital K. But a lot of times what we directly measure is Celsius. So I'll put this in parentheses, Celsius. And Celsius is represented with degree Celsius. And you notice there's no degree Kelvin, but there's a degree Celsius. And I'll talk about that later when we do temperatures in depth a little bit more. Now, another base unit, or unit that can be directly measured, is an amount. Not a unit, but a quantity is the amount. And that's represented with an N. And we call the unit a mole. And mole has a symbol of MOL. Now I know that's not shortened very much, but that's the way it is. You can't use M because M is already used for mass, distance, or meters, meters, so we have to write MOL. And in fact, anytime you have another unit like mile, you cannot use an M for that unit. You have to write out MI or MIL or something, because M means meter, not mile. Now these are measured directly, and a lot of students think, if we'll ask a question, well, what about volume? Can't you measure volume directly? Well, if you think about it, if I had a cube, how would you measure a cube? A cube, a solid cube, would be measured by length times width times height. That gives you volume. But that is a calculated measurement, and so it's called an indirect measurement, and it's not part of these base measurements. However, A lot of times, if we can measure volume as a base measurement if it's a liquid, because if it's a liquid, we can measure using a graduated cylinder, and the unit for liquid, or the variable, I mean, in an equation would be V, and the unit that we would measure in, the base unit, is liter, or liters, and it's a capital L. But only for a liquid, because if it's a solid, you actually have to calculate the volume of a solid. Even if it's not a regular shape, if it's irregular shape, you still, what you do is you get a measurement of a liquid, then you put the solid in that liquid, measure the difference, subtract the two. Okay, so because we subtracted, we actually did a calculation, and then you get the volume when you subtract the two different, the final and initial volumes. So it's really an indirect measurement. The other two that I'm going to show you are actually in physics. So these we use for chemistry. So these are the base units for chemistry. But the next two are what we're going to talk about are for actually, you know what, I'm not going to even mention it. It's on the PowerPoint. You can look it up on the PowerPoint. It's not that important. These are the ones that I really need you to know. So you need to memorize these things. You need to make sure you know them. Don't look them up. Now, once we have a base unit measurement measured, we can then use prefixes to give us different sizes of those measurements. So our prefixes we call it the metric system. So let's look at the metric system for a minute. And in that metric system, what I'm going to do is I'm going to draw a line here. And we're going to start out with base units here. So this is our base. And remember, base could be meters, grams, liters, and so forth. That's a base unit. We can directly measure those. We can also directly measure smaller units, but we need to have some way to determine the sizes. So as we do this, if I go this way on the table, things get larger. And as I go this way on this line, not table, but line, I said table just a minute ago, things get smaller. Smaller measurements. Okay, and one thing I want you to understand is that when I do this, we want to have the base unit on top. So I'm going to write fractions, so we're going to have base unit on top and the prefix unit on bottom. Okay, so the first one we want to look at in this, and we're going to do larger first, would be a kilo. So that's a kilo, and represented with a small k. Now a kilo, there are 1,000 base units in 1 kilo. So if I have a kilometer, so if I have 1 kilometer, it takes 1,000 meters to make 1 kilometer. So we put a 1 for the bigger unit, and how many small units make the bigger unit. Now let me clarify this 1,000 up here. I usually write 10 to the third, which is really equal to 1 times 10 to the third, which is equal to 1,000. So here you'll notice that we just assume or understand that the 1 is there when I write it, and that it's 1,000. Now the next one we're going to write here is a mega. And a mega is represented with a capital M, and it takes 10 to the 6th, or 1,000,000 megameters, or 1,000,000 megagrams to make, a 1,000,000 grams to make 1 megagram. Sorry, let me repeat that. I messed up the first time. It takes a million, it takes 1,000,000 grams to make 1 megagram. Remember the prefixes on bottom, 1 megagram. And the last one over here that we're going to talk about is giga, represented with a capital G. And a giga is 10 to the 9th over 1. In other words, it takes 10 to the 9th meters to make a gigameter, or 10 to the 9th liters to make a gigaliter. The larger one's on bottom. Now let's go smaller. Let's get smaller here. The first one we use when we get smaller is a deci. So we write, it's D-E-C-I. A deci represented with a small d. And again, in this case, the base is on top, but here the base is bigger because we're getting smaller. So we're going to say 1 meter is 10 decimeters. Okay? Next one would be centi, so C-I-C-E-N-T-I, represented with a small c. And we would say that 1 gram is 100 centigrams. Okay? And we go a little bit smaller. We make it milli. And that's represented with a small m. And milli, let's say 1 meter takes 1,000 milliliters. So 1,000 small units make 1 bigger unit, and the base is the bigger unit in this case. So we flipped everything. Going larger, the base is on top, and you need a lot more base units, and the bigger unit is the prefix unit. As we get smaller, the base unit is on top, and this is the prefixed units. Now, your book does things like 10 to the negative 3. In other words, and that's okay, and you'll see that. But what that says is that there's 10 to the negative 3 meters makes 1 millimeter. Now, I think that's backwards thinking, because if you think about it, if I asked you to tell me how many inches are in a foot, you would say 1 foot is equal to 12 inches. You don't say 1/12 of a foot is equal to 1 inch. So you don't make the fraction of the bigger one. You always say 1 foot is 12 inches. So that's what we want to do. We want to say the bigger unit we put a 1 next to, and we say how many small units make the bigger unit. So this is not incorrect. It's correct, but I don't want to use that. So I'm just going to cross through it that this is not preferred. Not that it's wrong. That's why I'm not going to put an X, but it's not preferred. Okay? I prefer that you think of it as put a 1 next to the big unit and how many small units make that big unit. Okay, that's what we want to think. So let's keep going down the row here. The next one would be micro. And so micro would be represented with this U that has this tail up front. Okay, that's a micro. It's really called a mu. But it's micrograms, so it represents micrograms. And so 1 gram is 10 to the 6th micrograms. So it takes 1,000,000 micrograms to make 1 gram, 1,000,000 small units to make the larger unit. The next one is nano, and that's represented with a small n. So 1 liter would be 10 to the 9th nanoliters. So it takes 1,000,000,000 nanoliters or smaller units to make the 1 base unit, bigger unit. And the last one we're going to talk about in this class is pico. Picos. That's represented with a P. And so 1 gram would be, or meter, gram, meter, or liter, doesn't matter. 1 meter would be 10 to the 12th picometers, or it takes 1 trillion picometers, which is a small unit, to make 1 meter, the larger base unit. Now the reason and it gets smaller, but we're going to stop here because we measure the size of an atom in picometers. We measure the size of molecules in nanometers. We do a lot of mass units and volume units in micro. Like whenever you take biology and you dilute things, you'll probably dilute things to the microliter. We measure a lot of mass in milligrams and centigrams, or distances in centimeters. So these are very important, and you are expected to memorize these and know these. You do not get to use a chart for this. So just remember how many small units make a single big unit. So I'm going to write that down. This is important. Think of it as how many small units make one larger unit. Okay, and that's the way I want you to process this. And so we'll stop here with measurement. The next thing is we're going to talk about precision and accuracy, and how do we determine and write or record precision and accuracy of measurements. So we'll stop here with this video, and I'll see you next time.